Afternoon BRITNEF, it's Mike here from Blastersmiths UK, and today I'm just going to give you a quick sneak peek of our very first prototype, version 0.1. 3 of these exist in the world, prototype board for a MOSFET controller board. Essentially this is designed to reduce the amount of faff that comes from installing a MOSFET board into your semi-automatic blasters. And what we have here is this version is hand-built, but the base board itself is manufactured here in the UK. It has your standard MOSFET on here, standard diode, a little tiny 10k pull-down resistor here, and these nice big solder pads for your wires to go to. Now this board is the version 0.1 prototype. There are literally 3 of them in the world, and there will only ever be 3 of them in the world, because by the time of recording we've already sent version 0.2 off to the manufacturers to fix a bunch of bugs which I will run through with you in a moment. So what I'm going to do is I'm going to take a strife, which I partially prepared earlier, and I'm going to show you what the features of the board have and how they work with boards. So as you can see here, you've got this header pin set up here. We provide you with a JST plug which allows you to plug in whatever control switch you're using. We then have these large solder pads in 3 locations for your ground wire, your V battery wire, and the motor negative battery here. I've already soldered up this motor block with stock motors because the Aussies are taking their sweet time getting their motors to us. I've also removed the jam door wiring, the magazine interlock there. I've trimmed off the switch leads here, and I've put a couple of holes in the battery tray to feed wires through. So what I'll do now is I'll just quickly finish off taking out the last of the stock wiring. As usual, it's always a good idea to keep hold of this thin wire. It's really useful for small low current projects or signal wire and bits and pieces like that. Obviously you can't use it for power applications, but it has its uses. So we'll get rid of that for the moment, put that to one side. Now, the board itself necessitates a slight change in how we do MOSFET wiring. But you'll notice it's got the diode on board already, which is one of the biggest complaints we used to get from people with MOSFET builds, was locating the diode correctly. You've also got the resistor, as I say. These blank pads here are for a stabilizing supply capacitor. That hasn't been added to this one because we really couldn't be asked after an hour and a half of learning how to reflow solder with a hob. We got bored and decided that this would do. So in the final manufactured version, obviously that capacitor will exist, but the board will look completely different anyway because this is a hand soldered by Steve board. And we've put me in charge of soldering up for the video because my soldering skills are nowhere near as clean as his, and if I can do it then probably means that anybody else can do it. So there's the board, 2 short lengths of wire here which will go on the board. This is excess length of wire which will also, one of the terminals will go to the board, the other one will go to the battery connector. This is the switch itself, and I'm going to do the wire joins on camera now. So we provide one of these JST male plugs here, and I've just dropped my soldering iron. Don't do that. One of these JST plugs here, and because we know from experience that wire-to-wire joins are really quite simple, we're just going to do the wire joins here so that people can have a really simple time of doing these. We did think about doing a version with 5 solder pads on it so that you could do 5 solder joins to the board, but we have felt that it was actually a lot easier to do wire joins for people. Now it doesn't matter which way around the polarity of this switch is. So the next component to solder is the positive, this red wire here. Now I'm not sure you'll be able to see this on the camera, but on each of the solder pads it has the colour of the wire that you should be expecting to join to that solder pad. So VBAT here is red, black is ground, and then on the other side here you have blue or yellow, depending on your high power or regular, the motor negative terminal. And talking about that, it has just occurred to me that I've actually just cut the wrong wire there. So you want to come with this yellow wire here. This is the negative wire from the motor terminal, from the motors. Okay, you want to cut that down, and you want to very quickly take some solder, twist your lead together, and then take your board, and for the motor negative terminal, take your board like that, take a strife, and mate the two together. There's a nice big solder pad here, so you don't have to worry too much. So just fix it in the grips until it works. This board is designed to eliminate the faff of setting up a resistor, setting up a thing. It reduces the number of solder joints down to 9 once you include the motor block, which is quite nice. Of course, it will affect the price of the wiring kits. They will have to go up by a few pounds because we have to cover our development costs. And the deployment cost of these boards is a bit more because we will have them professionally assembled here in the UK. As usual, we try and keep as much of our manufacturing chain here in the UK as possible. There you go, that's a nice simple join there. Just add some extra solder to it just to give it a bit more security. But the tin on your solder, on your soldering iron will obviously work quite nicely to bond to the copper and produce a nice heavy duty join like that. If you wanted to then cover that in Captain or liquid E-tape or similar, then you'd be well placed to do so. So the next one I'm going to do is the negative terminal. So this is a short black wire. It's going to run out the back here, enter the negative terminal of the XT60 connector. And this is just a case of quickly go up. I'm pulling off approximately 5mm of heat shrink tubing there, so that we can just simply, and so black wire is black here, goes there, and if we bring the two wires together, there you are, nice and secure. Right, and then finally, if we leave that one there, then finally we need a short length of red wire. Now you have to remember that this does not go directly to this wire here. Okay, you have to get the battery in somehow. So if you take your cutters and quickly strip off again 5mm or so off the end, pop it in the grips. Now I tend to, because I am a lot less skilled than Steve, we use me as the testing dummy when it comes to these sorts of things. So I always feel that if I can solder it and make it look relatively easy, then I imagine the average person on the internet can do the same. No matter how much I try, I just don't seem to be able to get the same quality soldering as Steve. So I just lack the patience. There you go. Okay, right. So that is now the 3 leads for the board all attached. Obviously, if you plug that in, then plug that in like that. Your switch is now attached. Okay, so as you can see, that isn't going to fit there with the thing. So what I'm going to have to do is I'm going to have to move it further forward to get this to function. That won't be an issue in point 2 because point 2 is, as I say, going to lay down, so it becomes slightly longer. It's about a 30mm long board, but it's dead flat. It'll slot almost anywhere. So that's it for now, folks. This is a BRITNERF special. I'm sharing it with you guys and only you guys, as a preview of what we're doing ahead of Tech Day. This is just the beginning, as I say. We've got lots of other shiny things planned, ready to go. It'd be great to see you there. I'd ask that you don't share this video outside of BRITNERF. It's just for you guys, because you're all awesome and you put up with our insane questions and all the rest of it. So that's great. Thank you very much for watching. If you've got any questions, do please leave them in the comments below or ask on the forum.